This is an example of a normal distribution problem. We're given that there are 2,000 freshmen at the U of M and they take a biology test. And the scores were normally distributed with a mean of 70. So I'm going to go ahead and write that down. Remember the mean notation. It's an X with a line above it. And we have a mean of 70. And then a standard deviation of 5. What we're going to do is we're going to label the mean on the graph below and label the 3 standard deviations from the mean in the positive and the negative, and then answer the questions. So I do have the distribution table up above for us to reflect on. So the first thing we do is we drop our mean first. So this is where our mean falls, and our mean is 70. So down below here I have 70. Now the standard deviation from the mean is 5. So if we go to the right, 1 standard deviation, positive, we have to add 5 to that score. So that would be a score of 75. Drop the line. Next one, we go 2 standard deviations, we have to add another 5 to the score to give us 80. Last standard deviation is 3. And we're going to add 5 more to the score of 85. Now we're going to go into the negative direction of standard deviation, so negative 1. We're going to drop by 5, so we're going to go down to a score of 65. Go down 2 standard deviations, drop another 5 down to a score of 60. And then to standard deviation negative 3, drop 5 more down to a score of 55. Now, we're going to use this percentages up here. If you remember, 34% of the scores are going to fall between that one length of our standard deviation of 34%. Same thing on the left-hand side, 34%. That total, 68% of the scores fall in between standard deviation of negative 1 and 1. Then we have 13.5%. and 13.5%. And again, I'm just taking this from up here, 2.35%, 2.35%. Last 2 is 0.15% and 0.15%. All right, let's go ahead and answer some questions with this distribution table, or distribution. What percentage of scores are in between 65 and 75? So if we look at, here is 65 and here's 75. So we add 34% and 34%. So 34 plus 34 is 68%. So 68% of the scores fall between 65 and 75. Now let's go to 60 to 70. So now our scores are going to go between 60 and 70. So we're going to add 13.5% and 34% together. And we will get a total of 47.5%. All right, go ahead and scroll down. The next question is, what percentage of scores fall between 60 and 85? I'm going to head back up. Between 60 and 85. So what we have to do is we have to add all of these numbers. Oh, not the last one. Not this one right here. Okay. So now when we add those, 13.5% plus 34% plus 34% plus 13.5% plus 2.15%. And we get a total of 97.15% of the scores fall between 60 and 85. Next question, what percentage is less than the score of 55? less than the score of 55. So here's a score of 55, and we're less for this direction. It is only 0.15%. Next question, what percentage of scores is greater than 80? Greater than 80. So here's 80. We have to add 2.35% and 0.15% together. To give us 2.5%. All right, now we're going to figure out how many approximate biology students score between 60 and 70. So we're looking at how many students. So we have to figure out the percentage first. So between 60 and 70, there was 13.5% and 34% of the group fell between those two scores. So we're going to add up those scores, 13.5% plus 34%. And we get 47.5%. Now remember our calculator cannot do percentages, so we're going to go ahead and convert this to a decimal, so 2 places to the left. And there were 2,000 total freshmen. So you multiply it by 2,000, and we get 950 students scored between a 60 and a 70. All right, last question. Approximately how many biology students score between a 55 and a 60? We head up to our curve, 55 and 60. So that's this region right here. The percentage is 2.35%. So it's 2.35% fell in between there. So move it 2 places to the left. And then multiply it by how many students are in our group. There was 2,000 biology students. When we multiply that, we get 47 students scored in between a 55